Hello student, welcome to maths class and today we'll do symmetry. Our learning objective in this chapters are line symmetry and rotational symmetry. So in this chapter we will read about the line symmetry and rotational symmetry. Start with the introduction. Symmetry is a key concept in the geometry. Observe the frequency of nature that apply across the various aspects of daily life. Professionals like artists, manufacturers, designer and architect all incorporate symmetry into their work. Many objects such as the leaf, flowers, clothing mats and the household item often feature symmetrical designs. So you can see symmetry in many things that is around you. You can see in nature also, like in animals you can see symmetry, in leaves, in flower pattern, on our clothes, mats. There are many things on which we can see the symmetry. Symmetry refers to the balanced arrangement of the matching shape. The term symmetry means that object can be split into two identical parts. So symmetry means that we can divide the object into two equal halves, which each part mirroring the other. In nature, we can observe symmetrical features in the both plants and animal. For instance, if we divide the leaf down the middle, we often see that one half is the mirror of other. Clear? So in nature we can also see symmetry. Symmetry is the common element of the beauty in the world around us. For example, butterflies. So you all must have seen the butterflies. You can see symmetry in butterfly also, and moths display the symmetry in their wings, with each side reflecting the colors and patterns of the other. Leonardo da Vinci, he was a famous painter, also explored the symmetry in the human body, which can seen in the paired organ like kidneys. You can see symmetry in our organs also, like kidneys, in the two halves of the brain and even the structure of skull. So you can see symmetry in many things. Like here you can see this line will divide the given butterfly into two equal halves. The other half is the mirror of the other part. So this is the line of symmetry. Some objects lack symmetry, such as irregular stone, certain letters of the English alphabet like F, G and J. They have no symmetry. Other letters display the symmetry in different way. For example, B, D and I have horizontal line of symmetry, while A has the vertical line of symmetry. So here you can see letter vertical line of symmetry in B, D and I. You can see horizontal line of symmetry. H shows both vertical and horizontal line of symmetry. So by observing the world around us, we find the countless examples of shapes and forms that are evenly balanced and aesthetically pleasing due to its symmetry. So symmetry makes the things beautiful. Next is line of symmetry. What is the line of symmetry? The figure that are symmetrical has a line of symmetry, also known as the mirror symmetry or the reflection symmetry. This line allows the figure to be folded such that two identical halves align perfectly. So this is an imaginary line which is split the given figure into two identical halves, and if we overlap it, it will completely, if we put the one part on another, it will completely overlap the other part. This dividing line is called the line of symmetry or the line of reflection. Look at this figure. So this have the vertical line of symmetry. Here you can see also vertical. It has both horizontal and vertical. This is horizontal line of symmetry. So here you can see the symmetry. There are line of symmetry in the nature, but normally we do not notice them. So you can see the symmetry in nature also. Human face, wasp, crab, you can see the line of symmetry. Now look at these pictures, these alphabet J, N and this figure. When we try the symmetry with these figure, when we try to fold letters like J, N along the line to create two identical halves, it does not work. So these figures have no line of symmetry or they are non-symmetrical figures. The term line of symmetry is also called the reflection symmetry because symmetry closely resembles to the concept of reflection. When the object is placed in front of mirror, so what will you see? You will see the image of that mirror of that object that is exactly same as the object. It creates the identical image of the same shape and size, like here you can see. In the examples mentioned earlier, we observe that the identical shape, same size but mirrored. Likewise, when the object's image reflects the water, it should show the line of symmetry in the water line. So you can see, if you see the reflection of something in the water, that water line act as a line of symmetry. Clear? Next is symmetry in 2D geometrical shapes. A polygon is defined as a closed shape formed of 3 or more line segments. When all sides and angles of polygons are equal, it is called the regular polygon. For example, an equilateral triangle is the example of regular polygon, because in equilateral triangle all 3 sides and all 3 angles are equal. A regular polygon with the 4 equal sides, a regular polygon are symmetrical shapes, and they have the many line of symmetry as they have the side or vertices. Now we will take an example, an equilateral triangle. If we talk about equilateral triangle, well, it has 3 line of symmetry. A square has 4 line of symmetry, like here. You can see these are 4 line of symmetry. A pentagon have 5 sides, it have 5 line of symmetry, like here you can see. Other geometrical figure or like polygon that are not regular also have the line of symmetry, but not as many as the number of sides. In these polygon, you can see they have as many line of symmetry as the number of sides. Now we will take the example isosceles triangle. In isosceles triangle, any 2 sides are equal, it has only 1 line of symmetry, like here you can see. A rectangle, opposite sides are equal, it has 2 line of symmetry. Scalene triangle, all sides are different, so it has no line of symmetry. Now we will take some examples. For the given figure, which one is the mirror line, L1 or L2? So in the given figure, you can see the line L2 is the mirrored line, because it is dividing into 2 equal halves. Clear? Next example, in the figure, L is the line of symmetry. Complete the diagram to make it symmetrical. So here L is the line of symmetry. So make it symmetrical. We will draw exactly same as given here, like this. It's like this. Next example, in the figure, L is the line of symmetry. Draw the image of the triangle to complete the diagram so that it becomes symmetrical. So we have to make it symmetrical. That means what we have to do? We have to draw a triangle like this. So this will become the line of symmetry. Clear? Next example, how many line of symmetry does this shape have? So this is a kite shape. It has only 1 line of symmetry because adjacent sides are equal. Clear? Next, how many line of symmetry does the equilateral triangle have? Equilateral triangle have 3 line of symmetry that we have discussed earlier also. Next is example 6. Can you think of figure that has 6 line of symmetry? Yes, a regular hexagon has 6 line of symmetry, like this you can see. Next example, consider a letter of English alphabet A to Z. List among them the letter which have the vertical line of symmetry, which have a horizontal line of symmetry and no line of symmetry. So you can see the vertical line of symmetry in A, H, L, M, O, T, U, V, W, X, Y. All these letters have vertical line of symmetry. Horizontal, all these letters have horizontal line of symmetry, and these letters have no line of symmetry. Next example. Given here are the figure of a few fold sheet and design draw about a fold. In each case, draw the rough diagram of the complete figure that would be seen with the design it cut out. So, you have to draw the design. If you unfold it, it will look something like this or like this. Clear? So, you have to draw the designs. Next is learning point 9.1. So, you have to practice all these questions. These questions are based on the concept we have covered in the chapter. Next is rotational symmetry. Now we'll read about the rotational symmetry. Rotational refers to object turning around a fixed point. So whenever an object moves around a fixed point, it's called as rotation. A rotation is same direction as the hands of the clock. If it moves in the direction of hands of clock, it is called clockwise rotation, and opposite sides is called anti-clockwise. For example, consider the rotation of ceiling fan blades. Do they spin in one ways or both ways? They always rotate anti-clockwise. Likewise, if you see the wheels of bicycle, they can rotate clockwise and anti-clockwise both. During rotation, an object shape and size remain unchanged. So if an object is rotating, its size and shape will not change, with the fixed point being known as the center of rotation. For instance, a clock, a center of rotation where the hands are attached, that is the fixed point around which the hands are moving. Clear? The degree of turning the rotation, that is called the angle rotation. So what is called? That is called the angle of rotation. A full turn, that is of 360 degree, while half turn, that is of 180 degree, and quarter turn, that is of 90 degree. At 12 o'clock, the hands of the clock are aligned by a 3 o'clock. The minute hand has complete 3 full turn, while the hour hand has moved quarter turn. Clear? 3 o'clock the minute hand will complete it will 3 o'clock the minute hand has complete 3 turn full turn, while the hour hand had moved quarter turns. Clear? The paper mill provide the good example of rotation symmetry. So if you have ever seen the paper mill, you can see what is rotation symmetry. It may appear symmetrical without having any line of symmetry. It has no fold to align its parts. However, rotating it by 90 degree around a fixed point will make look like the same. So if we rotate it by 90 degree, it will look same as the original one. This is called the rotational symmetry. In a full rotation, there are 4 positions: 90 degree, 180 degree, 270 degree, and 360 degree. There are windmill a pair identical, giving the rotation symmetry of order 4. So if you see the windmill, if you rotate it by 90 degree, it will look same. Then again you will rotate again 90 degree, means total 180 degree same, 270 degree and 360 degree. So 4 times it's coming into its original position. So it have the rotational symmetry of order 4. A square also exhibits rotational symmetry. If we start with the square, mark one corner as the point P and rotate the square by 90 degree about the center. Our point P will shift the new corner after 490 degree rotation. The square return to its original position, showing that the rotational symmetry of order 4. So in square, all sides are equal. So if we will rotate, its position will change, but its size and shape will remain same. So it has the order of rotation symmetry 4 times. Means 4 times it's come to its original position. 90 degree, again 90 degree, again 90 degree, again 90 degree. Clear? Next is key observation about this include. So what we have observed from all this, the center rotation is the square center. The rotation direction is clockwise. The angle of rotation is 90 degree. The order of rotational symmetry is 4. So in this is the center and it is rotating clockwise. The angle of rotation is 90 degree and 4 times it's coming to original position. So it have the rotational symmetry of order 4. Now we'll take some example here. Which of the following shape has a rotational symmetry above the mark point? So this is the mark point. So it has the all the above shape like 1, 2, 3 and 4. They have the rotational symmetry above the mark point. If we rotate it around this point, it will look same as the original one. Clear? Next example. Give the order of the rotational symmetry of the given figure above the point mark. So you have to give the order of rotational symmetry around this point. So in this, it have the order of rotational symmetry 4. 90 degree, 90 degree, 90 degree and 90 degree. Clear? In this figure, it has the order of rotational symmetry 3, and this is the rectangle. So here it is a rectangle around this point. It has the order of rotational symmetry 2. Clear? Note. Every object has a rotational symmetry of order 1 because it occupies the same position 1 after rotational 360 degree after a complete revolution. So every object will have the order of rotational symmetry at least 1 because during the complete rotation at least one time it will come its original position. So during the complete rotation, at the end of rotation it will come into its original position. So at least order of rotational symmetry 1, every object will have the order of rotational symmetry 1. Next example, which of the following figure have the rotational symmetry of order more than 1? So all these figures 1, 2, 4, 5 and 6, they will have the order of rotational symmetry more than 1. Clear? Next example, draw whether possible a rough sketch of a triangle with both line and rotational symmetry of order more than 1. So in equilateral triangle it have 3 line of symmetry and order of rotational symmetry is 3. So you can draw an equilateral triangle. Clear? A triangle with only line of symmetry and no rotational symmetry of order 1. So it is not possible to have such triangle which have only line of symmetry and no rotational symmetry of order 1. Clear? Third, a quadrilateral with the rotational symmetry of order more than 1 but not the line of symmetry. So that kind of trapezium is the example of that kind of quadrilateral. It has 4 sides and it has the rotational symmetry of order more than 1 but no line of symmetry is there. Clear? Next, a quadrilateral with line symmetry but not the rotational symmetry of order more than 1. That is not possible. So the quadrilateral with the line symmetry but not the rotational symmetry of order more than 1 is not possible. Next is learning points 9.2. So you have to practice all these questions given in the exercise. Next is summary. So here we are summarizing the chapter. We are taking the main points which we have covered in the chapter. 2 figures are said to be symmetrical if they coincide or can be superimposed. That means we can put the one part on another, it will completely overlap the part. This line of symmetry, the line of symmetry is divide the figure of the object into 2 mirror image. Any figure or object cannot be the both symmetrical and non-symmetrical. A regular polygon has as many line of symmetry as the number of sides. Clear? So here we end the chapter. I hope you understand the chapter well. Now to practice it.